Hi, I'm John White with Frederick & Company, the sponsors of the World of Private Offerings. Did you know that it takes 2,900 gallons of water to make a single pair of blue jeans? Be relieved. Blue jeans are not the primary cause of our water crisis today. Water, as we all know, is a limited resource. Our guest today will not only talk about this worldwide problem, but also a breakthrough technology that will add to our water supply by reusing water we currently waste today through contamination. Without further ado, I'd like to introduce John Grisdeel, CEO and co-founder of 9Power Clean Water of Golden, Colorado. Welcome, Gris.
Well, thanks. Appreciate it, John. And thanks for spending some time with me today and all the people that have logged on to learn more about 9Power Clean Water. I want to talk to you today about water and what our company is doing to help the planet make the most of our dwindling resource. As you know, water is the most important thing next to the air we breathe, and it's becoming even more and more difficult to come by. Scientists and researchers have been saying for years that the next big war will be fought over water. Well, no one can really predict if that'll happen. It is known that the total usable freshwater supply for ecosystems and humans is less than 1% of all the freshwater resources. And water use has been growing at more than twice the rate of the population increase in the last century. According to the United Nations, today almost 2 billion people, or 1/5 of the world's population, live in areas where water is scarce. Specifically, water withdrawals are predicted to increase by 50% over the next 20 years in developing countries and 18% in developed countries like the United States. So by 2025, 800 million people will be living in countries or regions with absolute water scarcity. And 2/3 of the world population could be under stress conditions, leading to the displacement of many, many people. Turns out there's only a limited amount of water on the earth, so how do we get more? Well, the most obvious thing is to recycle what we use. All kinds of water can be recycled or treated for reuse. This includes sewage or gray water from populations, seawater, and even industrial contaminated water. While most traditional engineering and construction companies build physically large plants using old technology, our motivation at 9Water has been to design and deploy modular machines that combine innovative technology in a manner that fits into people's existing workflows. The United States government figured this was going to be a problem too, and so they turned to Los Alamos National Laboratory for a solution just over 10 years ago. The LANL team's objectives were to invent the most effective water treatment solution for difficult-to-treat industrial contaminants, and then be able to deploy that solution for the lowest possible price. In 2013, 9Power Clean Water was founded, and we were granted an exclusive license to take the Los Alamos technology, turn it into products, and make it available worldwide. 9Power Clean Water put together a team that had the know-how and previous experience to bring together successful laboratory research and development, and we'd done so in the past. Now in 2018, technology has now become commercially available as a mobile, highly efficient, cost-effective, unique solution called the 9Water Treatment Plant. This solution took about 10 years and the assistance from the University of Texas at Austin and New Mexico Institute of Mining and Technology to develop, and it required 9Power Clean Water another 4 years to turn it into products that could be built and deployed all over the world. Today, 9Power Clean Water can treat water from the very worst contaminants and make it safely reusable. And we can provide this safely reusable water for pennies on the barrel, much less than what the oil and gas industry is currently paying, which ranges between $2.50 to $10 a barrel just to truck it off site and inject it into the ground. Other vertical markets include the textile industry, chemical factories, coking facilities, and oil and gas refining. I want to talk a little bit about the technology itself. It's fairly simple. It doesn't rely on chemical additives or lots of electricity, unlike other kinds of water treatment technologies. As you can see from the diagram, it's a simple series of tanks that utilize adsorbent, not absorbent, but adsorbent media that were specifically designed at Los Alamos to solve particular problems. For instance, we take out metals and metalloids in one container, and then all the other contaminants are allowed to pass through. This means that you've got a media that's specifically designed to just attract those contaminants it's after. And also it means that this modular approach allows people to implement our products in the way that fits with their workflow, which, as you can imagine, is very important in order to capture different market segments. People would like to leverage their existing investment in machinery. This next picture is a standard skid that'll process anywhere between 3,000 and 5,000 42-gallon barrels a day. It's interesting, the oil and gas produced water is actually measured in oil barrels, which are 42 gallons per barrel. And all around the world, we use different sort of volume and weight units for oil, natural gas, and water, but we kind of break everything down into either barrels or metric tons. In addition to the physical construction of our water treatment machines, we use specific media that was developed at Los Alamos just for each kind of contaminant that we're trying to remove. So again, that's metals or organic hydrocarbons, scalants, hydrogen sulfide, and even in the future, radioactive materials. The chart that you see here runs the great gamut of everything that we can remove. Oil and grease and suspended solids, those are the things that are floating in the water. They're actually pretty easy to get to. Biological organisms, well, our medias are natural biocides, so we can remove biologic bugs and organisms without the addition of chemicals along the way. We can also not only capture but destroy what are called dissolved phase organic hydrocarbons, and this includes things like benzene, toluene, petroleum distillates, things like that are found in a lot of industrial waters, especially in the oil and gas industry. Then more obvious things like lead and cadmium and chrome, iron, phenols, and various things that cause the absorption of oxygen and actually can cause problems if you take and put that water without proper treatment into a biologic area like a lake or a stream. And our machines eliminate all of those, and we do so for just pennies a barrel. Here's the chart that we actually prepared for one of our Chinese customer prospects. You'll note that our system removes, and almost hard to believe, 99% of all these elements. This is a completely revolutionary advancement in treating water for safe reuse. In most situations, we can assemble a system for our clients by adding or subtracting modules and components based on the amount of water that needs to be cleaned. Each system, again, handles between 2,000 and 3,000 42-gallon barrels a day, but we can gang those to treat up to 50,000 barrels a day. Total cost for treating machines, and our machines range in price from a couple $100,000 all the way up to $500,000 per module, and then you click together those modules to create very large plants. Works out to about 17 to 25 cents a barrel to treat produced water from the oil and gas industry, depending on what's on the water and what they want to do with that water, whether they want to reuse it in the oil and gas process, maybe for fracking, or if they want to use it to increase well pressure, and on the upper end, if they want to be able to discharge it to the natural environment. Now, this is a pretty big savings if you consider the fact that industry is paying between $3 and $6 a barrel just to dispose of this contaminated water. So instead of disposing of the water for $3 to $6 a barrel, we can actually treat it for 17 to 25 cents a barrel. Sorry, you can tell this is live because all my message notifications going on. So sorry, back to the point at hand. So we can do an incredibly effective job, better than most any other water system out there, and do so at a very, very small cost for the user. We sell the whole Nine Water system: machines, setup and validation, training, tech support, and maintenance, customized to address the composition of each client's water and their plant needs. Our machines are simple enough for a single part-time operator to manage all the functions of the machine, and we can also help customers find qualified personnel. One thing we don't, and we're not really interested in doing, is running a service. That's kind of heavy on the human resources department, and we'd much rather focus on being able to manufacture our machines and deploy them around the world without running a service to run the machines. Let's take a look at a couple of the industries that we work in. I've alluded to one in the oil and gas industry, but another one is the textile industry. Globally, there's about 62 billion pounds of textiles dyed each year to make apparel, and that uses up or contaminates about 5 trillion liters of water to do that. Not even including the amount of water it takes to grow fibers like cotton that are then turned into clothing. It takes about 2,900 gallons of water to produce a single pair of jeans. And then based on your kids and your own personal life, it might take that much to clean them on a regular basis too. Well, that water that the textile manufacturing industry uses contains a couple thousand chemicals, and in most developing countries, they're commonly this polluted water is commonly dumped into rivers and streams. Not only is this a huge waste of a precious resource, it's completely not necessary. And in places like China and India, over the last year, we've seen a huge rush to stop these kinds of contamination practices, and actually government money from both central governments in China and India, and to a lesser extent in the European Union, are being brought to bear to help companies purchase water treatment equipment. And we plan on getting in on that sort of rush to get green. Another segment that could use our help with its water use and reuse is the oil and gas industry. We talked a little bit about that earlier, but the oil and gas industry generates over 150 barrels of so-called produced water a year. This production or formation water accounts for about 98% of the entire waste stream for the entire oil and gas industry, from exploration all the way through to that gallon of gas at your local gas station. This produced water is 98% of that entire waste stream. Traditionally, this water has been taken, trucked off, and dumped into wells, and that's where that large figure of $3 to $6 a barrel comes from. But again, we can clean this water so it can be reused. It can be used to irrigate crops, for farm animals, and even put into human water consumption sources for 17 to 24 cents a barrel. And again, that beats the pants off of multiple dollars, $2 or $3 for other treatment systems, and as much as $6, $7 just to throw it away. Most people don't realize that fracking, and I know fracking's on everybody's mind, but fracking really doesn't use that much water at all compared to the amount of production water. And you can see in these photos, traditionally this produced water is left to sit around. Maybe it'll evaporate, concentrate some of the contaminants, but in that evaporation process, all those hydrocarbons are released into the air. And so that's something that most states have now prohibited. So the oil and gas industry has only got a couple choices. One is to treat the water, and again, the other is to do a deep well injection. And there's obviously some issues. You've probably heard about earthquakes being caused in Oklahoma and in Colorado and even parts of Texas because of this massive amount of water being put back in the ground. Industry's done a pretty good job at separating oil and gas from water. That's not really the problem. The problem is that they weren't able to get out all of those dissolved and even really fine particles, things again like metals, like arsenic, or the dissolved hydrocarbons like the so-called BTAX class of chemicals. That's benzene, toluene, ethylbenzene, and the xylenes. Those are the most dangerous organic hydrocarbons. There's many instances of when those have been banned around the world, and for good reason too. These BTEX compounds can cause cancer, birth defects, and a whole host of other things. It's not just dangerous for humans, but for crops too, because those organic hydrocarbons can be taken up into, say, vegetables or into grains, and then consumed by people without them even realizing it. So to help the oil and gas industry manage this volatile problem of way too much dangerous wastewater and what to do with it, which is also just discarded a valuable resource, one that we're running out of, we created this 9-water OG for oil and gas system. So I've said a lot, and sorry, John. Yeah, I heard you saying it's about time to get off the phone here. I would like to offer the opportunity for any of our listeners and our people viewing today. If you'd like to give us a call anytime, you can do so. You can find us on the internet at www.ixwater.com. You can certainly give John a call or call us directly on 303-277-9520.
Well, thanks a lot, Grizz. That was a lot of information, and I had a series of questions that come in here. And so maybe we'll start. I thought I had an interesting one. I thought there was somebody made a comment to say that if we're at 17 cents to 25 cents, and the current industry is paying $3 to $6, what prevents us from being widely? What if there's such a wide divergence? I think the question was that why hasn't this been widely adapted? It's just a matter of people aren't aware of it yet?
Well, that's part of it, but we really just started going to market this year. As I kind of explained, our capital structure has been such that we wanted to raise just enough to complete each phase. Acquisition of technology was around $500K, then about just under $2 million to get the product done, and that took several years. It's not something you could rush. There's a lot of engineering and a lot of chemistry and analysis, and quite honestly, there's a lot of interaction with the regulatory bodies to make sure as we're developing the product, it's going to meet the needs of the regulators, because they're really the only people that matter. I mean, the customers are the oil companies care, but their first question is, what's been your interaction with the various state agencies? What's been your interaction with EPA? So this new round of financing is to take the small amount of marketing we've done and really expand it. We've proven that taking a demonstration unit in the field that's showing oil operators on the spot their contaminated water going into our system and coming out clean. And I even do the silly dramatic thing of drinking the water that comes out of our system because it's so clean. That that kind of one-to-one marketing, you do that one time with an oil company, then they start talking about orders. Then they start saying, okay, now we need to do capital planning. We need to figure out how we're going to operate this. We need to figure out how it's going to impact our day-to-day stuff. The sales cycle is long, but it's because it's such a huge industry. It's 6 to 12 months from contact to contract and delivery. And out of that, the build's maybe 90 of those days. So that's why we started early, before we really even had marketing money, reaching out to companies that we already knew, to companies that helped us do the commercial validation. And that's how we've built our sales pipeline so far. We've also been working, as you know, in China to take our technology there and sell products, not to just sort of accidentally lose track of our IP. We have a couple very large plants that are pending there that quite honestly could make our sales expectations for the next 2 years just off a couple deals in China. So, in terms of the pricing though, my philosophy is that when you introduce a new product, we're not Apple Computer, right? This isn't some, glitzy thing. This is treating water. It's kind of boring. The exciting thing is what to do with the water and maybe your cost savings. It's not good enough to be a little bit better and a little bit cheaper. People to adopt a new system, a new way of doing business, a new way of operating in the field, you've got to be way better. And so I use this sort of 10-10-10 idea. 10 times better, 10 times cheaper, and then 10 times sexier, faster, whatever. That's what I've done in my career over the last 30 years when developing products. Because we've done, our team has done some kind of, they're pretty mundane, they're exciting to us, but water treatment, power plants, we can't do market-based pricing based on sexiness. We've got to do market-based pricing based on exceeding the expectations of the market. Now, even with that 70 to 24 cents, for the user to use our equipment, our gross margin is just north of 50%, and our EBITDA, within a couple of years should be around 25%. That's huge money. So if we can do that, satisfy the customers and really beat their expectations on price and effectiveness or efficacy, man, that's the combination that we need in order to really succeed.
Yeah, I think what I'm observing too is that, again, as you stated, Chris, you're at kind of the front end of the marketing cycle, introducing the product into the industry. But on your 10, 10, and 10 concept is that, a lot of people just look like, oh, well, we're just get a percentage of the marketplace. Our feeling is basically the nine water technology would essentially, within time, and we're not talking a long period of time, we feel it's going to be the adopted standard where, 5 years from now, 3 years from now, nobody's going to even think about trucking water away and throwing it on the ground. And so...
right, and it's all about execution at that point, and that's one reason why I think our team is so well suited, because we've not only taken products to market, we've actually proven that we can scale up and do manufacturing around the world, manage not our own sales team, but manage the resellers that are already touching those customers, already sell stuff to them. We want to be so ubiquitous that we're just another piece of equipment.
Yeah.
We're like a backhoe, right?
Yeah,
then know you've made it. I keep saying boring. The exciting part is the financial return, but the actual products, you don't want them to have flashing lights and all this disco stuff. What you want to do is fit well with the existing workflow.
Yeah, if you got extractor or frac or anything like that, you're going to need one of your units, and that's just an assumption that, just like you say, it's another piece of equipment that we got to buy.
It's a shovel, man, and that's what we want. And it's just a very expensive shovel.
Yeah, but that's where, frankly, that's where the fortunes are made, is in the shovels. One question came up on the IP, which is, you have the best of both worlds, but how does that translate in terms of the patent technology or the license?
So in terms of IP, our IP, we're managing a three-way ownership between Nine Power Clean Water Inc. of Delaware, the University of Texas, the Regents, and New Mexico Tech, which is, I think, called New Mexico Technology and Mining, Institute of Mining and Technology, but we always call it New Mexico Tech. So we share the royalty off those sales. Well, the royalty is artificially set by us at about 4%. So we pay ourselves part of that royalty. It's about one-third. So that's how the money flows. But in terms of ownership, we forever own the right to manage these patent rights. Right? You don't have to own the patent if you actually own. It's like owning the oil rights to a piece of land for 100 years. You don't need to own the land. So that's the same kind of analogy. And what it allows us to do, because we took the place of Los Alamos National Laboratory, and we didn't just do a license, we actually acquired a position in the patent that not only were we managing the patent rights and the technology, but we're one of the actual beneficiaries of that royalty scheme, is that we can dictate what we're doing. We're not just a licensee from the government, which is, to be blunt, normal, but Los Alamos did not want to be involved in a company that's probably going to be selling stuff in China or selling stuff, in Iran if it opens up, or selling stuff in North Africa. They just don't like that kind of PR. So they've sold their position in this patent. Now, so that's the patent rights. It's global rights to the technology. There's no restrictions on it. By the way, there's no import or export restrictions in the U.S., and we are not singled out because it's water treatment with any of the, sort of new and interesting administrations doing. Because it's looked at as humanitarian, nobody cares about water treatment technology and putting tariffs on it. Now, having said all that about the patent, the key thing that people need to remember is that we have 3 or 4 really key trade secrets, and that is what prevents people from stealing our technology. So it's how we make the media, and it turns out it's very difficult to do. We took the laboratory method of making the media, spent 4 years refining it to a manufacturing process. It's not obvious. It is complex. It's not expensive. It's just, it's a huge volume of media that you're turning into something that's not only reusable, but that's really effective. But the other thing is that pushing water through that media turns out to be non-trivial. And we actually had to go back to Los Alamos and have their top computational fluid dynamics modeling group help us figure out how to push water through this media without it getting clogged up. And so the interior design of our tanks is special. How we rate the pumps and how we run the pumps. You don't just turn on water. There's actually a system to how you do that so that you can get that water through the media. Otherwise, it'd sort of be like pushing water through, clay or something. So Those are two of the really key things that prevent people from just wholesale taking our technology from underneath us.
Yeah, and that comes up to another thing that I saw a question here is one of the things we observed or analyzed from our standpoint. I think it's really important to the investors is that, you kind of lead to the question is like, okay, how much it would cost from a time and capital standpoint to get to the point that you are today versus to what the company's valuation is and to what the current investors are coming in at. And this is where we thought this was just a tremendously unique investment because, again, you look at barriers to entry and that becomes kind of cliche and things like that. But when you combine what you just said from an IP standpoint and you look at it from an outside-inside standpoint to say, what would it take for some other company to do this, the amount of research, come to this position, put a competitive product into the marketplace, how much capital would have to be expended? And right now, we look at it today, the company has a relatively low valuation for this current round of investment based upon, what any other competitor would have to come into the marketplace would be 20-fold of what the investment is today. And so that's one of the reasons. So, and the current round, maybe you can speak to this a little bit, Grizz, is the thing that we like is $2.7 million, and I'd like Grizz to talk a little bit about, because we've had questions about that, how much more capital are you going to need beyond that? Because one of the things we see is that the company can reach a cash positive position without having multiple rounds after this. So you can speak a little bit about that, Grizz.
Well, since this is the 9th startup, one of the reasons it's called 9Water, 9Power, I've been through a lot of different capital models, and so I've kind of been selfish in that way, and it really benefits our investors. I lived through, as you did, John, the internet boom and bust, where it seems like we had these outrageous valuations, and we could raise as much money as we wanted, and we could go do acquisitions, and money was freely available. Actually, there's more money in the system now and less good deals from a private equity standpoint. My point is that we've been very cheap as we develop this. I mean, my salary over the last few years has been sort of $4,000 a month, right? I'm not taking a normal salary because I know that every dollar that we spend, whether it's paying myself or paying the other people in the company or wasting money on expensive office space, that dilutes us down. So my sort of desire to make a lot off of this deal has kept our capital needs lower than even what another startup would do. Now, in terms of a company, one of our advisors is a guy that used to be an executive at Dow, and he has spent the last 6 months looking at the technology, trying to understand sort of how we got here. We leveraged a lot of work that was done at Los Alamos. Then they applied, conservatively $10 million to the project over 8 years. Then we spent kind of a minuscule amount of money, just under $2.5 million, getting the product to this point where it's ready for the market. It's proven commercially in the field. We've run many field tests. You see my hands look like an oil guy. So all that is to say that to replicate what we're doing, Ningka thinks it maybe as much as $100 million to get where we are, and then you'd run into our IP. So it's much easier to buy a system that's complete, that's ready to go, or to work with us in a collaboration to develop new technology based off our stuff than it is to try to replicate what we did. There's just the build versus buy, scenario. Buy is definitely easier. Now, as far as more capital, we're done. Our goal is to make sure that this technology, these products is ubiquitous, but we don't have a desire to go raise $250 million to set up manufacturing around the world and to set up, sales offices in all the oil-bearing regions or in the textile industry regions or something like that. What we're really good at is proving the business model, getting the thing out there, building the value for our investors, and then it's likely that we're going to do, that we'll be acquired by somebody within a few years. Somebody like Siemens or GE or Veolia that has this global footprint already, that already has global manufacturing. Just like somebody entering this business now wouldn't want to replicate what we're doing, we don't want to replicate a multi-billion-dollar company. That costs capital, and in the end, our shareholders, they really don't get a higher return. It's the get in early, get out early money that has these high returns. And this is following, the high-tech Silicon Valley model. You don't see Sequoia hanging around inside of Facebook, 10 years after its founding. They put their money in, they got their return, they're gone. So we kind of modeled this deal after that idea of get in early. The investors get a stake. We're taking the company broadly. On the global stage, proving out what we need to prove about the company, and then letting our investors get out. So they're not hanging out 5 years from now saying, "Oh, gee, I've doubled my money." No, I want them to make 8, 10x in a couple of years, and our projections prove that out, show that. So
yeah, well, I think that answers the question. We had a couple of questions come in terms of, and you answered it in terms of the exit strategy. And again, one of the things that we look at is that the exit strategy and philosophy of the company, or the practicality of the exit. And I think Grizz nailed it in the sense is that having myself a Silicon Valley background is that current investors, although it's open to individuals and other kinds of investors, this is the stage where venture guys actually get into a deal and then get out of a deal within 3 years. And it's not often as an individual that one would see this type of an opportunity where a company is going to marketplace. And again, here's the nice thing is that the current investors don't have to labor through the 10 years, 8 years, 5 years, all that R&D took. And normally somebody comes in and says, "Oh yeah, we'll put money into this deal," and now you have to have this gut-wrenching 4-year period to see whether it's going to work or not. That's gone.
Yeah, we don't do research and development. We don't do what I call science, right, which has unknown outcomes. We do engineering and product development, which, at that point, if the science is proven out, and it was by Los Alamos and their own field testing, out in Chevron fields, out in different venues over the years, by the time we get the technology and then turn it into a reproducible, commercially viable product, we're doing engineering, right? That's got known outcomes. Science, like, will this work? We don't like doing that, and our team has never done that. We want proven science that's ready to be put into the marketplace, and then we help make that transition. But it also means that our investors never have this risk of research.
Yeah, small R, big D. Yeah, small R,
yeah, that's
big
right.
D.
That's exactly. Yeah, more emphasis on development. But again, we're much more comfortable on the engineering side. We follow established patterns. We do everything ASME standards. We don't try to reinvent the wheel. We're just putting our technology, out there, into the existing market space.
Yeah, and again, the exit strategy, Grizz related to it, is that the company, Nine Power, is on the road to establishing how to reuse water, like, for example, in the oil and gas industry. And once that becomes like, oh my God, just like you said, you got to have this piece of equipment. Just about that time, somebody's going to wake up at a Siemens or a large company and says, "Hey, that's a business we want to be in." Okay.
Yeah.
Well, what they're good at is not trying to develop that type of business or compete against somebody like Nine Power. What they're really good at is making a strategic investment in a company like Nine Power, and then taking it to $1 billion company. And that's exactly how Nine Power is being positioned. And that's what we like because, again, we can talk with some confidence, as Grizz related to, is that at today's value, we can talk in a real practical sense that's what gives somebody within a 3-year period that invests today an 8 to 10 return on money without having to essentially endure the science of the risk of science. And that's why we think this is extremely unique.
Well, and one additional comment on that, John, that I'll make is, let's say that 3 years from now we decide maybe we want to roll up this industry, right? We want to go buy some different kinds of manufacturers that broaden our product offering. We need to go raise $100 million. I'm still going to let our current investors give them the option to get out and recapitalize the company. That is a different company, right? We've got a singular focus right now that's specialized in a certain areas. If we ever decide to go broad, that's a new balance sheet. That's a whole new thing. And so obviously we give people the opportunity to stay in or get out. They have the right. It's not like that I can dictate that to them. They have the right to do it. So.
Yeah, so that's what we see is attractive. So right now we're right in the midst of a 2.7 raise. We think that we got probably a 60-day window before it all closes out, and it's going out rapidly. So again, I want to try to wrap it up today. Is that everybody that viewed today, we're going to be in contact with you 24 to 48 hours, and also we have just opened up this week, which we'll send you the links to, and you can get access and register for the Frederick and Company investment platform. On this platform, everything you can see about 9Power, from the business plan to the PPM to Grizz talking and showing the equipment and talking about the industry, to several good ebooks and videos, are there for you for your due diligence. So again, we'll send that out to you and be in touch with you next 24 hours. And we really appreciate the presentation, Grizz. And again, anybody that wants to contact Frederick and Company or Grizz directly, feel free to do that. And so we really thank you for your attendance today, and we'll keep you in touch. Thanks a lot.
Okay.
Thanks a lot,
Thanks,
Grizz.
John. Talk soon. All right. See you.